All right, so what we're gonna do for just a couple minutes is on the first page of the new packet, there are 5 empty boxes. And what I'd like you to do in those 5 empty boxes are answer these 5 questions as best you can. They don't have to be right. Just do your best and the top 5 boxes there. Thank you. So again, your take-home test is due tomorrow at the start of class. A 0 on a test will kill your average. We plugged it into an average student's grade right before break, and it dropped their grade by getting a 0. It brought their class average down 14 points. If they got 100, it did bring their class average up 5 points. So it is a pretty big grade either way. So you're going to either want to make sure you have it completed and probably as close to 100 as you can. So make sure you get that done for tomorrow if you didn't already hand it in. All right, how are we doing with our time here? Do we need a few more minutes to answer these, or we got them? Nobody's willing to answer. All right, let's do it anyway. So we may have already kind of covered a lot of this since we did go out of order in this packet. So if you notice at the top of this one, it does say chapter 7, part 1 at the top of it. The one you just finished up and are turning in your take-home test, that was actually chapter 7, part 2. We went out of order, but it probably didn't make much of a difference. So let's go with box number 1. What do you guys think meteorology is? Yeah. Yes, it is the study of weather patterns. If you got that wrong, let's just go ahead and enter the correct definition right there below. So if you have it wrong in the box, that's okay. So down on the lines that are in the middle of the page, what is meteorology? It is the study of the Earth's atmospheric changes. In other words, it's the study of weather. So again, this is the first thing in your notes. So it goes on the lines there in the middle of the page. The boxes were just to get your juices flowing this day after break. Nobody thought it was the study of meteors. Are we past that? Or did some of you? Because that would have been the better answer, right? Nothing in science can be straightforward. That would make sense. That would definitely make a lot more sense than meteorologists studying the weather. But whatever. I'm not in charge. So I'm guessing you know that a meteorologist then is a person or a scientist who studies the weather. So you can add that to the next bullet there. So then what do you think weather is? There you go. Wow, you got that. It is the short-term conditions of the atmosphere. We know just from yesterday that those clouds can disappear really quickly. Did anybody get a good view yesterday? Yep, speaking of clouds, yesterday was kind of a bummer, but I don't know about you guys, but it cleared literally just in time for us to see totality at my house. It was pretty impressive. Yep. Well, even just seeing it, how cool was it when it got dark? Like how it instantaneously went to darkness. That was the part that, like, we all know what it's like when the sun goes down, but it doesn't go that quickly. Yeah, we saw bats. Yep, the bats are out. No, it was definitely bats, I'm guessing. Oh, yeah. All right. So then finally, since we're talking about a bunch of atmospheres, so meteorology is the study of atmospheric changes. Weather is the short-term condition of the atmosphere. We better make sure you have a solid understanding of what the atmosphere is. So what do you guys, how'd you define atmosphere originally? Golden? So a gaseous layer surrounding the earth. That's pretty good. Did anybody add anything else to that? So you're not wrong. There are just a few more details. In fact, if you notice your bullet or what you said is almost my exact first bullet here. So it is a shell of gases surrounding the earth, but let's 10th grade that up a little bit. That shell is then divided into layers based on temperature changes with altitude, which is height above earth. If you know what altitude is, you don't have to write that part. Normally I would have you go on to that next box that says, so what is the difference between weather and meteorology? We're going to skip that part. I just want to make sure we get done what we need to get done. We are, if you didn't notice, did anybody notice my countdown started on board? We have 44 class days left until the end of school. That's class days. No, I wouldn't have wrote it if I wasn't excited too. That does not count weekends. It does not count days off. That counts our very last day as 0 days left. So it might be different, kind of different countdown depending on different teachers, but that's how many days left after today. Yeah. Stand by here. Our official last day of classes is June 13th. It's a Thursday. Oh God, come on. Yeah, actually, did you say 14th?
Yeah.
Yeah, I thought it was the 14th. That's a half day for RK Delavan. No school for K through 8. So we're getting there, guys. 44 is not that many. After this week, we're in the 30s. Like, okay, I know. I'm excited and nervous all at the same time. Every year it comes together. So we have this chapter, a very short chapter 8, and then chapter 9, and we're done. This one, by the way, isn't that long either. So we will be done probably in the middle of May, and then we'll start reviewing after that. All right, so let's keep going then. So on that note, if you turn the page, we have a reading, and you guys know what readings mean in my class. The next page is where we're going to be looking for notes. So we're going to read the reading and then get the information from the reading. So first off, if we look at page 3, you'll see what we're looking for in the reading. So we're going to be talking about energy. You guys did a little bit of energy stuff when you were in 8th grade. So some of this stuff might start sounding familiar, but just like with the definition of the atmosphere, we're going to 10th grade it up a little bit. So we're going to be looking for in the reading internal energy and the causes of that. We're going to be looking for the definition of external energy and the causes of that. Actually, no, not causes. That one's going to be what it's affected by. And then we're going to be looking for the definition of a word called insolation. Not insolation, I'm not saying it wrong. Insolation. Are you ready to be looking for these definitions, causes, and what they're affected by? How do you want to do this? Do you want to read through it on your own, or would you like me to read it? Own? Yeah. Okay, then I have a request. Don't write the definitions or anything yet. Who wants a highlighter? Anybody? Ready? Oh, that was a little low. Anybody else? I like throwing markers at people. It's the one thing I get to do as a teacher that kind of gets some aggression out. Anybody? Sure. That's good. Yes, you want me to do one. Would you like me to gently deliver one to you? No. Okay. All right, guys. So go through the reading. You're looking for the definition of internal and external energy. You're looking for the causes of internal and what affects external. So take a few minutes and go through that reading and look for those answers. Did you find in the reading, what is the definition of internal energy? Yeah, go ahead, McKenna. Internal energy is energy that comes from inside the earth. And did you find the two causes? Somebody different. What? You got one? Radioactive decay. By the way, does that word sound, those words sound familiar? Okay, remember the half-life stuff? There's actually one thing I never mentioned when we were talking about half-life. So when those radioactive elements turn into their stable decay products, so remember we had Twizzlers that turned into poop, or uranium that turned into lead, those also give off heat. So they give off energy and heat while they do it. But I did not mention that while we were doing it. Did you find the other cause? Yeah. Yes. Is that up here in the same energy that is left over from the formation of the planet about 4.6 billion years ago? So if you don't already have those, let's fill them in the actual notes section. So I shortened it up a lot. Internal energy is, I should probably say energy from inside the earth. In fact, I'm going to. Oops, apparently that doesn't like that. So that is energy from inside the earth. Perfect. And you had the two causes, the radioactive decay and the heat left over from the formation of Earth. All right, so if internal is energy from inside the earth, what's external energy? You got it. You guys are geniuses. In other words, we call it solar energy. It is energy from the earth. And there are three things that affect how much energy we get from the earth. Did you find all three? Why don't I give you a minute to go back and look, see if you have three things that control how much energy we get from the sun. Find all three? I found them. I have them highlighted since I stopped talking to you. Someone, thank you. Madison, give me your first one you find. I know, I'm sorry. I just punished my first volunteer. You got it. The first is the angle the sun hits. I'll put it up in a second, but I want to get all three first. So first is the angle. Yeah. Yeah, the time the sun is in the sky, how long it's out. And did you get the third one, anybody? That one's a little trickier. Anybody else besides TJ and Madison? Nobody else. TJ volunteered first. Thank you.
How much to be atmospheric?
It is basically how much the clouds are out. So here are the three. Since some of you weren't speaking, make sure you get all three word for word here. The first is called the angle of insolation, which just means the position of the sun in the sky. All right, we good? Or do you need a minute to keep copying? So in those definitions, we use the word insolation. Again, I'm not just saying insulation wrong, not the pink fluffy stuff in your attic. That's not what I'm talking about. Yeah, not the cotton candy, Nick, not the cotton candy. Insolation is this word right here. Insolation comes from the words incoming solar radiation. I think it's legit a made up word from those three words. So if you notice, we have in from incoming, sol from solar, ation from radiation. I guess it's, yeah. Not, yeah, that's it. Sorry. Ooh, that's my spelling coming out there. So incoming solar radiation. So insolation is just talking about the sunlight that is coming into the earth, incoming solar radiation. So it's really just talking about solar energy. The last thing we're gonna do for today, and if you could grab your reference tables, I'm gonna add that to my list up here. Pick up packet and a highlighter. Your ESRT, we're going back to page 14, which I believe, have we been at that one already? So we'll come back to that compare and contrast tomorrow as a quick review. Earth Science Reference Table, page 14. You will find 3 separate charts on this page, but we are going to be focusing in on the top part of that page, which is the title, for some weird reason, is off to the side. It's called The Selected Properties of Earth's Atmosphere. So this is, kind of looks a little overwhelming at first, 3 separate graphs. These 3 separate graphs, we've got a temperature graph, a pressure graph in the middle, and a water vapor concentration graph at the end. Each one has its own x-axis, but if you notice, they all share the same y-axis, and that's altitude above Earth's surface. So guys, where is 0 kilometers or miles above sea level? That is the ground, not just the ground, but that's the ground at like New York City. Why did I pick the ground at New York City as 0 meters or kilometers or miles above sea level? It's right by it. In fact, it's surrounded by the Atlantic Ocean. If you picture the Statue of Liberty, she is standing in the ocean. So they are officially at 0 feet above sea level. Who's got their phone out? Cam, do a Google search, please. What is the elevation of Yorkshire, New York? Cam always has her phone out, so it's easy. Wait, let me write it down. What is it? 1,697 feet. This? No. What's it say? Let me see. Yeah, feet, not inches, feet. Yep. Okay, so just good to know. So we're not at 0 miles. We're close to 0 miles. We're not up to a whole mile yet. But anyway, that's height above sea level. So if we went to a place like Colorado, where they're up in the mountains, or where my brother lives, he lives up in the mountains, he would be higher up on this chart. If you take an airplane, you go up the y-axis, you're higher above the ground. So the x-axis, or the y-axis, I'm sorry, is a little goofy because they do it in miles and kilometers at the top. You can bet your bottom that they're going to try to mess with you there. So if they ask a question, make sure you read the units really carefully. Are they asking about kilometers or miles? Because as you can see, like 40 kilometers is the same as 25 miles. Those are very different numbers. 40 miles and 40 kilometers would be in 2 different parts of the atmosphere. So just be careful when you're reading it. One thing I'm hoping you notice are the layers. Do you see the dotted lines? They're the dividers between the different layers of the atmosphere. Hopefully this first one at the bottom, troposphere, that should sound familiar. We learned about that one the first couple of days of this year. It's on the front page of your reference table, even if you don't remember learning about it, right here on this chart. When we talked about the different elements in each layer, they did include the troposphere here. So the troposphere is the closest, it's also the smallest layer. Then we have the stratosphere, the mesosphere, and the thermosphere. Be careful because the dotted lines look a lot like those words too. So the troposphere and the stratosphere are divided by the tropopause. So make sure you read the whole word, not just the front half of each word. And what do you notice about the temperature as you go higher in the atmosphere? Does it? Could we say just the temperature rises as we go through the atmosphere, we get higher up? No, because it doesn't just get higher. It might end higher, but it doesn't just do a nice steady getting higher. What does the temperature do? Let's take a look as we go from the ground to the tropopause. So we're standing here on the ground, and let's take a hot air balloon to the tropopause. What has happened to the temperature when we went from the ground to the tropopause? It goes down. We start at 15 degrees Celsius at the ground. And if you were to take that hot air balloon up to the tropopause, you can see, what is the temperature, by the way, at the tropopause? -55. They were nice enough to label that. That's pretty cold, because remember, freezing is 0. So that's pretty darn cold. But now we're going to, okay, we can't take a weather balloon anymore. Let's take an airplane. There's my airplane. So once we get out of the weather balloon and into the airplane, what happens to the temperature there? It does go back up. How hot does it get at the top of the stratosphere at the stratopause? So if you follow that dotted line, we're just at 0. So while the temperature did increase, it's still pretty darn cold. Then you can see the mesosphere. You should be noticing the temperature gets even colder, all the way down to -90. But then once we hit the mesopause and go up through the thermosphere, you can see we're going to get well over 100. One thing I want you to notice, did you read this little note here under the words thermosphere? What's it say? It really goes to 600 kilometers. Does this chart go to 600 kilometers? But the thermosphere itself goes to 600 kilometers. What do you think is going to happen with the temperature in the thermosphere as it goes up past this 120 kilometer mark? It just keeps going up. We don't know how hot it'll get. You just know it will keep getting hotter and hotter at that same slope. So it'll get hotter and hotter and hotter, but they did not include that on your reference table. It just would have been a lot of extra pages. So the temperature varies. It goes from gets colder, warmer, colder, warmer. Does that same thing happen with the pressure? No. What happens to the pressure? This time we can say one complete thought about the pressure. As we go up in the atmosphere, what happens to the pressure? Yes. This one messes with people because we read it differently than we normally do. Because we are talking about going up in the atmosphere. At the ground, the pressure is 1 ATM, 1 atmosphere. And then the higher you go, the less atmospheres are on top of you. We already talked about that. So hopefully that one was easy. What about water vapor? It does go down as you go up. Why do you think they don't put a line up here? What's that mean? There is no water vapor up here. So the water vapor ends just above the tropopause. There is no more water vapor. Once you get into the tops of the stratosphere, the mesosphere, and the thermosphere, there is no more water. So actually that leads me to one more question. Guys, what are clouds made out of? Water. So where are the highest clouds then? Okay, they don't get above right here. And with clouds, what comes with clouds usually? Rain and wind and disgusting stuff that we've been having all last week, by the way, for those of you who stayed here like me. It was awful, wasn't it? But anyway, all the weather happens down here in these 2 layers. There is no weather once you get above these layers. In fact, so for those of you who did go somewhere in an airplane, what did you see when you looked out your window while you were cruising if you looked down? Clouds. Airplanes go right above this line. So because they don't want to be in the clouds. Clouds equal weather, which equals turbulence. So planes fly just above that. Easy enough to read? Let's see how easy it is. In the first one, in what sphere? So if you didn't already fill this in at the top, that should be page 14. So we're right on page 4. We'll just do these quick 4 questions. So what sphere is all, or maybe I should say most of the water vapor found? Okay, so if we go back, there are 2 layers that have water vapor. Which one has the most? Yeah, the troposphere. I've also heard it pronounced troposphere. I don't know which one of us is right. You keep doing you, I'll keep doing me. So the troposphere is the one that has most of the water vapor. So now take a look at the atmospheric pressure chart. What happens to the pressure as altitude increases? It decreases. So if you are confused about this, ask yourself, what is it at the ground? 1. What is it when you go up to the tropopause? Well, it's less than 1. So the pressure does decrease. So number 3, we kind of just answered as well. Which sphere does all the weather occur in? Again, that's in the troposphere because that's where the weather is. And finally, what happens to the pressure in each of this, or I'm sorry, the temperature in each of the spheres? What happens in the troposphere? What happens to the temperature? Decreases. I wrote goes down either way. Now take a look at the stratosphere. Increases. Oh, I went the wrong way. So stratosphere increases. What about the mesosphere? That one decreases. And the thermosphere increases. Now, again, if you don't know where that information went, because I only heard a couple of you answering. So where did that come from? It comes from this graph right here. As we go up through the troposphere, the temperature goes from 15 to -55. So that's decreasing. The stratosphere increases a little bit. Mesosphere gets colder. Thermosphere gets warmer. One more quick review and then we're done, and no homework other than your test if you still haven't finished it. First couple days of school, we learned how to do this question. Write the composition of the troposphere in the table below. Do you remember what page to refer to? ESRT, page 1. So I want the percent and the element there. So we're looking down here at this chart. We have the percent in the crust, the hydrosphere, and the troposphere. I only want to talk about the troposphere today. So it's 21% what? Oxygen. So 21% oxygen. %78 what? Nitrogen. And 1% other. What are all these empty boxes? None. They don't have any in there. Now, does anybody find that weird that most of our atmosphere is not oxygen? Didn't you think most of what you were breathing was oxygen? It's not. Only 21% of what you're breathing is oxygen. You're breathing in mostly nitrogen. All right, so we'll pick up with this chart tomorrow, making sure you're comfortable reading it. And don't forget to do your take-home test tonight.